Welcome to this explainer. Today we're unpacking a high-stakes reality that literally every homeowner dreads, but we absolutely have to prepare for, and that is sudden basement flooding. It's one of those things that usually gives you zero warning, right? A stretch of heavy rain, rapid snowmelt, or just sudden groundwater pressure can completely overwhelm your home's drainage system in a matter of hours. And we aren't just talking about a little puddle on the floor. We're talking about significant, costly damage that essentially turns your basement into a surprise indoor swimming pool right when you least expect it.
So, I want you to ask yourself right now, is your basement truly protected? Because when that heavy weather hits and the water table starts rising, a single device is rarely enough to guarantee your safety. Water moves incredibly fast, and just hoping for the best, well, that's definitely not a strategy. What we're going to learn today from our source material is that surviving a major weather event absolutely requires a proactive mindset. A well-designed sump system paired with the right backups and a totally clear, rehearsed response plan can dramatically reduce both how much water enters your basement and how long it stays there. Okay, let's dive into this roadmap for taking control before, during, and after a flood. We're looking at 1. Knowing your sump pump, 2. Size and capacity matter, 3. The ultimate backup plan, 4. When the water rises, and 5. Drying and future prevention.
Section 1. Know your sump pump.
Our emergency arc really begins with peacetime preparation. Before the storm clouds even gather, you need to deeply understand your baseline defense system, which is the sump pump you probably already have. At its core, this whole system relies on a sump pit. That's basically just a basin designed to collect water. The pump sits either inside or right above this pit, and it works to move that collected water safely away from your home's foundation, usually pushing it through a dedicated discharge line. So many of us have one of these sitting silently in a corner of the basement, but we kind of don't fully grasp how this essential piece of hardware functions until we absolutely need it to.
And here is a major reality check from our source material. Quote, most failures aren't about the pump breaking overnight. End quote. We really love to blame a broken machine, right? But the true villain here is usually poor preparation. When a basement floods, it's super often because the system was undersized from the start, maybe poorly installed, or simply missing vital supporting components. It's like a giant puzzle with missing pieces. It's a system failure, not just a pump failure. So the crucial point is that you need to audit your own setup right now. Seriously, don't assume it's fine just because it's plugged into the wall. You need to verify the basic details. Do you know your pump's rated discharge capacity? Go check the type and height of the float switch. That's the little mechanism that actually tells the pump when to turn on. You also need to physically trace the discharge line path. Ask yourself, is there any risk of freezing or blockage where the water exits the house? And critically, ensure that your system actually includes a check valve. Because without a check valve, the water your pump just worked so incredibly hard to push out, it can just flow right back down the pipe and into your pit. No way we want that.
Let's move to and see how this builds into Section 2, size and capacity matter.
When you realize your current system might be lacking, the natural instinct is to just go buy the biggest, baddest pump on the shelf. But actually, selecting a sump pump is a really delicate balancing act. Its capacity has to perfectly align with your home's specific drainage needs. You've got to factor in environmental variables. What's your local rainfall intensity? What kind of soil is sitting around your foundation? How big is your basement? And how quickly does the groundwater rise during a major storm? All of these factors dictate exactly what you need. Because if you have an undersized pump, it's going to run continuously. That puts immense strain on the motor without ever actually keeping the pit dry, and that eventually leads to a devastating overflow right when the storm is at its absolute worst.
To get this exactly right, our sources highly recommend having a qualified contractor evaluate your system. But you can absolutely proactively benchmark its performance yourself. The next time you have a known high water period, say just a moderate spring rain, literally go down to the basement and watch it. Observe exactly how quickly the pump kicks on. But more importantly, watch to see if the basin level returns to normal completely before the water starts rising again. If your pump is struggling during a moderate rain, it for sure is going to fail during a severe one.
Section 3. The ultimate backup plan. Now we are introducing the absolute hero of your defense strategy, the backup plan. Because an unpowered pump literally means a destroyed basement. And this brilliantly illustrates the massive contrast here. Without redundancy, a simple power outage transforms a manageable situation where you might get minor flooding at worst into total, catastrophic loss. A truly dependable backup strategy doesn't just rely on one single thing. It combines multiple layers of redundancy. First up, you need a battery backup to keep the system running when the power goes out.
Next, depending on your home's layout and your local building codes, you might want to consider a water-powered or secondary electric pump for mechanical redundancy, just in case the main pump's motor completely seizes up. Layer 3 is alarm monitoring. Think about it. You want a system that alerts you to rising water, a pump failure, or a power loss so you don't discover a disaster hours after the fact. And finally, those check valves we talked about earlier to prevent backflow. Stacking these layers is what actually prevents catastrophe. But hey, a quick reminder, even if you have backup power, you absolutely must test it regularly. A backup that hasn't been tested is just a silent failure waiting to happen when urgency hits.
Section 4. When the water rises.
Okay, we've talked a lot about peacetime preparation, but let's shift gears to the adrenaline-pumping moment of a severe storm. The exact moment water starts rising, you are in an active emergency. During those first 15 to 30 minutes, your only goal is to stop water from entering and keep that system working. Obviously, if it's safe to do so, go verify the pump is actually running. Listen to it. Does it sound like normal operation? Actually look at the pit and check if the water level is dropping. If you have an alarm blaring, confirm exactly what that alert is telling you. And if your main power is out, you need to verify right away that your backup system has successfully engaged and is fully carrying the load.
Now, what's really interesting about this slide is that your response shouldn't just stop at the sump pit itself. You need to actively reduce the amount of water coming in from the outside. So if applicable, close any nearby interior water sources. Then, safely go outside and clear any obvious obstructions in your downspouts or exterior drains that might just be dumping water straight against your foundation. Back down in the basement, prevent any random floating debris from getting sucked into the pump and clogging the intakes. And this is a big one. If water is coming in, grab your smartphone and document the conditions with photos and videos right then and there. You are absolutely going to need those for your insurance claim later.
Section 5. Drying and Future Prevention.
Eventually, the storm is going to pass. But listen, your job is not done just because the standing water receded. You cannot just assume you're safe. Damp materials left untreated will lead to mold and a super toxic lingering odor within mere days. It happens incredibly fast. You need to deploy heavy-duty fans and dehumidifiers immediately. And if materials like your drywall, the insulation, carpeting, or any stored items have been soaked for an extended period, you really must consider calling in a professional for an assessment. Real structural drawing is entirely different from just wiping up a puddle with some towels. Once you are fully dried out, prevention becomes your absolute best friend. You have to reduce what feeds the problem in the first place, and this is especially crucial for those of us in regions prone to heavy Midwest rain and rapid snowmelt. So make it a regular habit to inspect your gutters and downspouts. Make sure they are flowing far, far away from your foundation. Check the grading and the drainage pathways of your yard. Ensure your outdoor drainage systems aren't getting choked up by seasonal leaves or sediment. And back down in the pit itself, do some periodic maintenance. Check for any silt buildup at the very bottom that could eventually choke the pump, and manually verify that the float switch can move freely without snagging on the walls of the basin. Look, basement flooding is incredibly stressful, but as we've seen from our source material in this explainer today, you absolutely have the power to reduce the risk of major damage. It really just takes a properly sized pump, multiple layers of mechanical redundancy, and a practice response plan. So I'm going to leave you with this final thought. Have you tested your backups before the storm clouds gather? Please do not rely on luck when the water starts rising. Go review your setup today, test your systems, and take full control of your home's defense. Thanks for joining me on this explainer, and stay dry out there.